Hey everyone, I am going to be making a video on the homework of three variable systems, and that way you can not only see how to transfer from words to equations, but how to use substitution elimination to solve. So it says Heather downloaded some television shows. A sitcom uses 0.3 gigabytes of memory, a drama is 0.6 gigabytes, and a talk show 0.6 gigabytes. She downloaded 7 programs total. There were twice as many episodes as dramas. So we're going to write a system for each. So whether it's money, percents, point whatever of data, there's usually an amount piece to it for every equation. So it's 3 gigabytes for a sitcom, we'll write S, 0.6 gigabytes for a drama, and then 0.6 gigabytes also for a talk show. So is there a total amount of gigabytes? Oh yeah, 3.6. So I'm going to add all those up and get 3.6. This is going to be the reoccurring theme over and over again. Whether it's money, percents, whatever, it's amount per amount per amount per equals total amount. And then it said she downloaded 7 programs. So then there's just how many exist. So how many sitcoms, dramas, and talk shows exist. This one is so simple that it seems complicated. And then there's always a comparison equation. There were twice as many episodes of drama as there are sitcoms. So twice as many drama as sitcoms. So if I take 2 times S, that will be drama. This is one students have a hard time with. So they're like, I don't know if this equation's right. We'll just make up a fake number. So sitcoms, let's say you have 7 sitcoms, then you would have to have 14 drama. So it says there were twice as many episodes of drama. Yeah, 14 and 7. So you know you did it right. So you know that you didn't have to do 2D equals S. So kind of write what you think it is, put some fake numbers in, and does it logically make sense with the problem? Then you did it right. Probably for all these, you're going to use substitution. So if D represents 2S, every time you see a D, you're going to replace it. So every time you see a D, you're going to do 2S. So let's do that. I'm going to erase this. So your new equations are going to be 3S, or 0.3S plus 0.6. We said D was 2S plus 0.6T. And then S plus D, which is 2S, equals 7. So now we have a system where it's 2 variables, and we've done that since Algebra 1. So let's clean it up. Like I said, if you initially use substitution, then you can use elimination as you continue. So here we have 3S plus T. Oops, why did I write T? Equals 7. And then here we have 0.6. So it's going to be 1.2 because 0.6 times 2 is 1.6 times, or 0.6 plus 0.6, which is going to be 1.2S. So we're going to have 1.2S and then a 3S. So it's going to be a 4.2S. And then you have a 0.6T, and that's going to be 3.6. Then you're just going to solve the system like normal using elimination. The answers and all of this worked out. Like it's an entire page. I have it super long worked out for you on your classwork section, but that's how you get started. Okay, so let's try another one. Okay. So let's go to your classroom. What were all the ones I posted? Seven and then 20 through 24. So going to your textbook, let's go to 20. Okay. It says a friend sends you the results of a high school swim meet. The email states that 24 individuals placed, earning a combined total of 53 points. The first place earned 3 points. The second place, so we could do 3 points for the first place. We could do second place earned 2 points and third place earned 1 point. Second place and then third place. Okay. It said there were as many first place winners as second place and third place winners combined. So first place was the same as second place and third place combined. So we have a comparison. We have 3 points, 2 points, 1 point equals a total of points. Where's the total points? 53 points. And then we also have one there's 24 individuals placed. Okay. So if there's 24 people, how many first place winners were there? How many second place and how many third place? So you're gonna have 3 equations. You're always gonna have a comparison one for these word problems. So every time you see an F, you're gonna replace it with S plus T. Every time you see an F, you're gonna replace it with S plus T. So it's not 3F anymore, it's 3 times the quantity S plus T. Plus 2S plus 1T equals 53. And down here, we're gonna replace F with S plus T, and we already have an S plus T equals 24. So you take that one equation, substitute it into both. Once you do that, clean them both up. So it's going to be 3s plus 3t plus 2s plus t equals 53. So then it's going to be 5s plus 4t equals 53. And then there's 2s plus 2t equals 24. That's it. Then you can decide, you want to make this 10 or negative 10, 2 or negative 2. This one's probably easier. I'd multiply by negative 2 and solve the system of equations like you have been since Algebra 1, Geometry, in this class. To see this fully worked out, go into your classwork, and under Chapter 3 is the homework answers, okay? Let's keep going. It says, Nick goes to an amusement park to ride roller coasters, bumper cars, and water slides. So immediately I see 3 things. That's the amusement park. I see roller coasters R, I see bumper cars B, and I see water slides W. Boom. I write as I go. Or you know what? Probably a proper way, since you guys are new at this, is just read the whole thing and go back. So let's do that. Nick goes to the amusement park to ride roller coasters, bumper cars, and water slides. The wait for the roller coasters is 1 hour. The wait for the bumper cars is 20 minutes longer. The wait for the water slides is only 15 minutes long. Nick rode 10 total rides during his visit. Because he enjoys roller coasters the most, the number of times he rode the roller coasters was the sum of the times he rode the roller coasters he rode the other 2 rides. If Nick waited in line for a total of 6 hours and 20 minutes, how many of each ride did he go on? Whew. Okay, let's break down this information. Nick goes to the amusement park ride for roller coasters, bumper cars, and water slides. The wait for the roller coasters is 1 hour. The wait for the bumper cars is 20 minutes long. And the wait for the water slides is 15 minutes long. Nick rode a total of 10 rides. So we know that he rode all of these, and there's 10 rides. How many of each? Because he enjoys roller coasters the most, the number of times he rode the roller coasters was the sum of the times he rode the other 2 rides. If Nick waited in line for a total of 6 hours and 20 minutes. Okay, so the total is 6 hours, 20 minutes. But we know for the roller coaster, it's 1 hour. For the bumper cars, it's 20 minutes. And for the water slides, it's 15 minutes. Here's the thing. I can't have an hour. I can't have 20 minutes, 15 minutes, and 6 hours. You have to be all in minutes. So I'd say this is 60 minutes for the R, 20 minutes for the bumper cars, 15 minutes for the water slides. A total of how many? So 6 times 60 is 360 minutes, plus 20 to be 380 minutes. So you have to convert everything. All right, same situation. Amount, cost, time, percent, whatever, and then a comparison. So every time you see an R, put in B plus W. Every time you see an R, put in B plus W. You're going to substitute and then clean up. So this is going to end up being 2B plus 2W, because another B is 2 B's, another W is 2 W's, equals 10. Then down here, you're going to have 60 times B plus W plus 20B plus 15 equals 380. Clean that up, then create elimination again. Okay. Once you get the flow, it's the same thing every time. Okay, so let's go to your next page.